Hi, this is Randall Schwartz, host of FLOSS Weekly. This week, Dan Lynch joins me. We're going to talk about something very important to the entire virtual internet, KVM. It's behind the scenes of everything you're probably using. You're not going to want to miss this, so stay tuned.
Netcasts you love.
From people you trust.
This is TWiT.
Bandwidth for FLOSS Weekly is provided by CacheFly at CACHEFLY.com.
This is FLOSS Weekly with Randall Schwartz and Dan Lynch. Episode 229, recorded October 17th, 2012. KVM. It's time for FLOSS Weekly, the show about free, libre, open source software. I am your host, Randall Schwartz from MerlinAtStonehenge.com, bringing you each week, or almost each week, I'm so sorry about last week's cancellation, the big projects, the little projects, the movers, the shakers, things you might not have heard of, things you may be using every day, including today's project. But we'll get to that in just a second. Let's go ahead and bring on our co-host, Dan Lynch. Welcome back to the show.
Hello, Randall. It's always fun to be here.
Very good, very good. And this week's show, I think, is going to spark a lot of interest because pretty much everything we've been talking about this year pretty much has been about virtualization and, about being able to use big hardware for multiple people and being able to scale well and all that sort of stuff. This week, we have none other than Avi Kivity and Dor Lauer, I hope I'm pronouncing those correct, talking about KVM. What do you know about KVM, Dan?
Yeah, I know, well, a reasonable amount about it. It's a kernel virtual machine. And yeah, it's really, really interesting. Actually, you've mentioned that it's kind of behind a lot of the things we've been talking about this year. We've talked about overt, we've talked about libvirt. This is the thing that powers those. So if you've interested in those, this is the kind of the power behind the scenes, if you like. Yeah,
essentially makes a real physical hardware be able to be used by multiple virtual hardwares, essentially by providing, like, everybody gets their own namespace, everybody gets their own address space, that sort of thing. And Avi, I think, has actually been on the project since the beginning, so we'll be able to get some history from him as well. That sounds pretty fun. Let's see, anything else before we bring on our guests?
No, can't wait to hear more about it. Let's get them on.
Let's go ahead and bring on our guests then. Let's first speak to Avi. Avi, welcome to the show.
Hi, great to be here.
Very good. And where are you speaking to us from?
We're from Nana in Israel. It's near Tel Aviv.
Okay. I'm going to be in Israel, in fact, in 2 weeks. I don't know exactly where I'm going, a couple of short excursions from the cruise I'm doing. I don't know if I'm going to be anywhere near you, but it's good to talk to you. And let's also welcome Dor onto the show. Dor, welcome to the show.
Hello, good to be on.
Very good, very good. And so I gave sort of an overview at the beginning of the show about what I believe KVM to be in my limited experience of it, although it seems to be ubiquitous in everything I'm doing around me. Why don't we start with like the 30,000-foot view? Avi, do you want to take that and tell us sort of like what KVM is and what problem it solves?
Sure. KVM is a hypervisor. You can use it to virtualize a host that you have. If you have a large host, then you can divide it into several smaller virtual machines and run various guests on them, and each can have a different operating system. And there are a lot of uses for that. The main use right now is to divide large machines into smaller ones, because the machines we have now are so large that they're really difficult to use with one large workload. They're also very useful for QA, where you run different operating systems and test applications on different setups. And really, there's a huge amount of uses for virtualization, and KVM solves the problem very well by reusing all of the facilities from Linux that are well tested and well designed, and have this huge community of developers designing them. So KVM reuses all of that effort and puts it into a hypervisor.
Okay, so you have a machine running Linux running with KVM installed, I guess it's something like that, or it's a loadable module somehow. And then you're running another operating system or maybe another instance of Linux, and it thinks that it has the entire machine to itself, but it's really just taking up a part of the machine, right?
Exactly.
Okay, and how did KVM start? What's the history of it?
So KVM started when the company that I worked for, Kubernetes, was looking around for a solution that did the virtual desktops, and we wanted to do live migration. At that time, the open source solution was Zen, but it did not do live migration for Windows guests, which is what people usually use for virtual desktops. And I know this is FLOSS Weekly, but that's the way it was. People used Windows. So in order to have a live migration, we looked around and we thought about using Zen, but it was quite difficult to add that at the time. So we tried to do our own and be unique in that. And that's what we did, and it turned out to be quite easy. Linux had almost everything that we needed. All we needed to do was add support for hardware virtualization. And once we did that, everything worked very well.
Okay, a couple of terms in there I want to make sure that our audience understands. What is live migration?
Live migration is where you move an application or the entire guest from one host to another, while the application is, and the guest is totally unaware of that move. So you can do it in order to take the host into maintenance mode, while the guest is totally unaffected, and note performance or even inside of a change from the guest perspective.
So is that something like if I'm using like one of the many virtualization softwares I have for OS X, like VMware or something, is that the same as like when I just take a snapshot and freeze the machine and then I bring it back up and the machine's not really aware except the clock all of a sudden jumps forward a day or two? Is it something like that?
Yes, except that the machine is still live while you do it. And you don't really freeze it. You just move bits of its memory to another machine, and it's still processing, and there is a cutoff moment, but it's nearly instantaneous, where it stops running on the original host, and it continues running on the destination host, and it's seamless and very nice to watch in practice.
So actually, I could be like SSH or something into one of these boxes and not even know it moved.
Right.
Wow. Okay, that sounds cool. That sounds like a really cool facility. The other word I wanted to make sure we got defined, and it's probably going to be essential to a lot of our rest of our conversations. What is paravirtualization?
So paravirtualization is a technique that was, I think, pioneered by Zen, at least on x86, where instead of emulating the hardware exactly as it is, you make modifications to the hardware you emulate to make it easier and more efficient. And Zen took this approach very far. They redefined the x86 architecture for that. But most hypervisors, including KVM, don't go that far. They just they usually redefine or define new PCI cards for block devices and for networking, and that allows them to be more efficient, use less CPU, and give better bandwidth or IOPS. Also, we sometimes use them for things that are more low level, like the clock, to get better timekeeping, but usually we don't do that for the architecture itself.
So in other words, I could use an operating system sort of native, but the way it would talk to its I/O devices is by waiting for interrupts and moving block memory in certain ways and things like that. That's sort of how an operating system talks to a real physical device. But so if I understand this right, paravirtualization is that you're providing some sort of higher level interface. You're just simply saying, put this block out on the Ethernet rather than having to move the block to the right place in memory, then wait for an interrupt and wait for all that to happen. Is that a fair way to say it?
It's close. For KVM, we emulate really a PCI device. It's not a PCI device you can go out and buy because we've defined it. But it's still, for the guest, it looks like just another PCI device. So from that point of view, it's not very far from native. But the way that this PCI device is designed is that those operations become more efficient when running under KVM because they're designed to minimize the amount of transitions between guest mode and host mode, which are fairly expensive on virtualization hardware. And by minimizing those transitions, we make the whole thing faster.
Okay, guys, so we've got some questions already coming in the chat room, and people are watching and listening live. And there's a few people asking a few kind of background things, so we might have to kind of back up a little bit. But a lot of people asking what's, the kind of the history of KVM in the kernel. What version did it come in, and can they, what version can they expect of the kernel? Do they need to be able to get KVM as well? So when did it actually come in?
So KVM was first merged in, I think it was 2620, maybe around 7 years ago, quite far. I mean, we've changed the numbering system since then. I barely remember those versions. And since then, it received updates for every kernel version, and we've improved the reliability, the performance, the scaling. Nearly every aspect of it is improved in every version.
And we've had a question from Mir, M-I-R, in the chat room, who was asking me, in fact, whether this was only for Linux. And it was my understanding that it was, because it's Linux kernel virtualization. But apparently they were talking about some talk of Solaris and Illumos and so on. So can this go beyond the scope of the Linux kernel, or is it strictly for Linux?
So KVM itself is just for Linux, but there are some crazy people that try to port it to other operating systems. And the first port was for Windows. And there was another port for Solaris, which I think is actually used in production. But the main development is Linux only.
Yeah, that's what I always thought, yeah. Sorry, carry on.
I'm sorry. A port for Windows, for example, won't be as good as a port for Linux, or maybe for Solaris, because the code is controllable. Although KVM is a model and it's pretty isolated, it has hooks into the scheduler, the memory management, and it makes everything more efficient through integration, a really good integration with Linux. These type of things are not available on Windows, at least for not for Microsoft employees. So that's don't expect to get similar performance of KVM on Windows, and in fact, it was more of an academic experience.
Okay, yep, that makes total sense. And quickly, someone else is just asking, this is a very kind of high-level question, but they were asking what the difference between something like VirtualBox and KVM would be. And my kind of explanation would be that us kind of Unix beards, we tend to refer to it as userland, so anything that's not in the kernel. So VirtualBox would run in userland. It's an application that's running within your normal OS. Whereas, as my understanding goes, KVM is in the kernel, so it's in the actual core. It's a much lower... It's embedded at a much lower level. Is that a fair kind of description?
So actually, VirtualBox does have a kernel component. So in that, it's not very different from KVM. And really, there are different implementations of the same idea. KVM is a lot more integrated into the kernel. There are a lot more APIs that KVM uses to talk to the kernel, and that the kernel uses to talk to KVM to inform it, for example, of memory pages being swapped out to disk, so that KVM knows that it should unmap them from the guest. And this kind of integration is only possible if you have if your code base is in the kernel itself.
Yep, that makes total sense. And in terms of the kind of the virtualization landscape, shall we call it, one of the big names that always comes up that's been around a long time is VMware, which is proprietary, obviously. But how would you compare KVM and what you do now in kind of performance and so on with other big names that people might know, like VMware, for example? Do you do like benchmarks against those kind of products?
Oh, indeed we do, and I have a lot of respect for VMware. They're very good at what they do. But if you look at benchmarks posted on the spec website, there is a SpecVirt benchmark. Then I believe that 7 of the top 7 results in the SpecVirt are KVM results. So we hold the 1st through 7th top positions.
If we can give even more details, SpecVirt was defined by VMware and a bunch of others in the spec committee, and in fact, KVM outperformed any result by VMware over the factor of more than 100%. And it's not that we're more efficient by twice of VMware, but our limits are much more higher because we're basing on Linux. We stand on the shoulder of Linux, and that's why we're much better and much more efficient. In all terms, even if we check face-to-face, head-to-head on the exact same hardware, KVM gets better results. So that's an awesome experience. And from at the beginning, we were puzzled to get these amount of amazing results. But after thinking more and more, the base idea is that a hypervisor needs lots of components like a similar OS needs. It needs memory management, I/O stack, scheduler, NUMA support, multi-core, etc., etc. And all these components were developed in Linux for the past 20 years. So VMware, although they started with virtualization before, don't have as good as OS for managing the hardware, the physical hardware, as we do. And that's why we outperform them in performance.
So looking at the idea of what virtualization is doing, what is KVM actually providing? My sense is that it's basically letting the operating system that's being virtualized sort of run until it would hit an illegal instruction in user land space, and then somehow trying to figure out how to pretend that that's happening. Is that a good way of saying what that virtualization is doing?
Yes, that's a good description. And the virtualization hardware in modern systems allow you to define which instructions you want trapped and under what conditions you want them trapped. And then when the trap happens, it describes the exceptional condition that happened and allows software, in this case KVM, to take control and emulate the effects of the instruction and pretend, show to the guest the state that would have happened if it were running on real hardware.
So an example of that, just so that we can make it more concrete for people, is like a normal operating system has to manage the memory map hardware for its user processes. In other words, that my address 0 is actually memory address 1,000,000 or something. And so it has to map that somewhere. So a virtualizer has to trap the instructions that would change the actual memory mapping hardware and then map it through to its own memory mapping hardware. Is that sort of a good sense of what it has to do?
That's actually what was happening up to a few years ago, but modern hardware actually does those translations by itself. And this is one of the reasons why virtualization has been improving so fast. It's because the hardware has been doing more and more of the job that the hypervisor used to do. So in this case, that's what happens on older hardware, where every time you change the mapping between virtual addresses and physical addresses, then KVM intervenes and changes the mapping in the background to point at the real host page instead of the virtual guest page. But on hardware, this no longer happens, and things are a lot faster due to that. And this trend continues. Every year or every processor revision, we have more and more of the jobs of the hypervisor being moved to hardware, and the hypervisor and the hypervisor developers can just sit back and relax and watch the performance increase.
Wow. So what's the because in the old days, I'm a graybeard, so I get to talk about the old days and virtualization back in the early days. So what's the overhead now? Is it on an average CPU mix? Are we talking in the order of 5 to 10% now, or is it even less than that?
So the standard answer is that it depends on your workload. But if it's a CPU-intensive workload, then it will drop to almost 0. If it's an I/O-intensive workload, especially a ping-pong type workload, bandwidth is usually very good. But if you have a ping-pong type workload, then you will see a larger performance drop. But usually you can be within 5%.
Wow, that's pretty awesome. So so Red Hat bought the company that made KVM. You mentioned the name earlier. Sorry, I forgot it already. What's Red Hat's interest in this?
So Red Hat, of course, controls the Linux server market and has a huge market share there. And there is a new market that was opening up in those days, the virtualization and the cloud market. And to play in that game, you need to have your own ball. And KVM was that ball, both for cloud, which we see everywhere. Almost every public cloud right now is using KVM, and also for enterprise virtualization. Red Hat now has a product that uses KVM, and it's a great product.
If I can even describe it further, Red Hat didn't have a hypervisor back then. It had the Zen hypervisor, and we still support it. The issue with then, it wasn't merged into the Linux kernel, and only these days it's really totally merged into the Linux kernel. So it was a really lengthy time to get that merged, and it didn't play well with the community. And not to mention, that's another component that needs to go between the hardware and the operating system. So it's cost in terms of development, and it's cost in terms of performance. It's just a waste of another scheduling entity. So that's why Red Hat wanted to go to the KVM solution, which was more appealing in that sense. In addition, for the bare-bone hypervisor, Kubernetes, that was the name of the startup, we had an infrastructure for managing virtual desktops. So that was to run farms of virtual machines running desktop VMs. At the time, it was only Windows XP. It was long ago. So we had really good management to manage such a cluster of lots of hosts, up to hundreds of hosts and lots of VMs. And nowadays, we ported that product that is capable of running virtual desktop and virtual servers all together in really, really good performance and friendly. And if we're comparing VMware product to this, it's like ES6 and KVM are similar targeted, and vSphere and RevM are targeting the enterprise market. And of course, now OpenStack comes in, and the KVM is the default hypervisor with OpenStack, and we have a product for OpenStack that was recently announced.
We had a question from the chat room about porting from Zen to KVM or migrating from Zen to KVM. Would the applications care, or is this just a matter of management, or is there now some difficulty moving across?
So usually there's no problem in doing that transition. Zen, because it relies so heavily on paravirtualization, used to have a different kernel, which was quite a pain. But if you switch the kernel, or if you're running a newer distribution which has a unified kernel for both Zen and native, then you can run the same image on both KVM and Zen. And usually there's zero problems in the transition.
And what's the relationship between KVM and QEMU? That keeps coming up as I keep Googling for this.
Yeah. So what KVM does, the kernel component of the system, is emulates a processor. But a system has more than just a processor. It has peripherals, a network interface card, block device cards, and the rest of the system is a lot bigger than just the processor. So the job of QEMU is to emulate the rest of the hardware, all of the hardware excluding the processor, and also provide a management interface where you can send commands to the virtual machine emulation, like a hot plug a processor or a PCI card, or unplug them. So all of the higher level functions are done in QEMU in user space, where it is easier to develop and where a bug does not take down the whole system, just that one virtual machine. So it's better in terms of both development speed and security.
So it's sort of like, if I can relate it to VirtualBox, because I'm much more familiar with that, VirtualBox has an app on my OS X side that I'm double-clicking on, and actually I interact with as a GUI and stuff like that. But VirtualBox also has a few components over on the kernel side to be able to do like some high-speed data processing or whatever the device processing is. So QEMU is sort of like that double-clickable app for me, right?
Yes, exactly. And in fact, VirtualBox also uses QEMU for this application at its core. And also Zen, everyone picked up QEMU because it is so extensive and it supports so many different hardware. So practically all of the open source virtualization is based around QEMU.
Okay, and let's see. I've got a couple more questions from the chat room here. Oops, it scrolled by already. What's on the roadmap here? What's still missing in KVM, and why is it missing, and how soon are you going to get it?
So KVM is actually pretty feature complete. So we're still adding features because it's never done. But for a casual user or even an enterprise user, everything is there. One feature that I'm excited about is not really a feature; it's a new port. It's a port for the ARM architecture. So ARM recently gained virtualization extensions, and it's starting to become a player in the server market. And I'm very excited to see this ARM port and to see this new market. And I'd like to see KVM take a big bite of this market. Thor?
Well, there are actually so many new features that are coming in. So I can talk on and on about them. It can go through dynamic resource provisioning, so you can add virtual CPUs and in the upcoming future, memory hot plug and unplug into the guest. You can do not only live migration, but we have various optimization to that, and we can do the live block migration. So copy the disk of the virtual machine, not just its RAM. We have enhanced security, and that's interesting story in terms of the Linux community, because Google were developing a sandbox solution, and we chose to develop with them a solution that will go and play well both with QEMU to sandbox the virtual machines from other virtual machines, and this sandbox is used in the Chrome browser in order to sandbox the browser itself. And the nice thing in Linux is that it utilizes an existing filtering language to filter syscalls, so the sandbox process, in our case, is QEMU, won't be able to do malicious calls or unforbidden syscalls that weren't configured to that purpose. In addition, I can talk on and on about new NUMA optimizations that will increase the out-of-the-box performance by 10–20%, but let's see what your viewers want to say.
Yeah, so how can an operating system tell that it's being run under KVM? I mean, is there a way for it to sense that, or does it just really think it's on bare metal?
Sure, it's no great secret. It can use a CPU ID instruction, and we have defined a bit there that tells whether it's running under a hypervisor or on bare metal. And there is further a signature, which it can check and compare against the signatures of known hypervisors. So it can very easily tell that it's running under a hypervisor. Also, it can run various instructions that are trapped, and it can figure out just by the slowdown that it must not be running on bare metal.
Okay, well, the reason I asked that, I'm leading into my next question, which is, can you run a Linux KVM kernel under KVM?
Yes, this is a very interesting feature. It's called nested virtualization, one of the hardest to implement. And this is supported both under AMD and Intel. We have different instruction sets for virtualization. So we needed to support both of them. And you can do that. I would still consider it experimental, at least on Intel. And the performance is not that great. It's not the great performance that you usually see on KVM, but it works. It's very useful for debugging. I've used it for debugging KVM several times. And it's pretty amazing to see your guest. You can call up guest under that guest, and you can do that indefinitely, or at least as long as you have enough memory and processing power.
Yeah, I asked this sort of, I've been told that KVM, the Linux module, the Linux loadable kernel module, will load under FreeBSD as well as Linux. And I have a FreeBSD virtual machine that's running under KVM QEMU at the hosting site that I use, ARP Networks, who's been really good to me for all these years. So I was just wondering if I could try loading KVM under that and running something beneath that. It sounds like it might be fun.
So you could, because it's experimental, you need to set some parameters to make sure it's enabled. But in theory, it should work. But again, I don't recommend it for production. It's great for testing and for looking around, but don't do this. Do this at home, not at the office.
And so, how is KVM in the field of players? Who's your horizontal competitors? Like ESXi, I think, is one. The VMware offering. Who else is out there in the field that you're sort of competing with?
So it's the usual suspects: VMware, Microsoft, and Citrix. And I think that in the cloud, we're a clear leader. In the enterprise, everyone has their share.
And over the last few months, we've had a number of people from Red Hat talking about the various levels in the stack. How does KVM fit into that stack? Who sits just above you, and why are they talking to you, and how does that work?
Can you clarify? I didn't really get the question.
Oh boy! So we've had people like libvirt and a bunch of other. I'm trying to remember all the Red Hat people we've had on this past year. So where are you in the stack of things? It's sort of at the bottom, right?
Oh yes, we're all the way at the bottom, and everyone's above us. Below us is just the bare metal, unless we're running on nested virtualization. So there's KVM on the very bottom. QEMU on top manages KVM and uses KVM to virtualize a processor. Libvirt talks to QEMU and configures it and sends its command in real time to migrate or to do various things. And above Libvirt, there would be the management stack, RevM, that tells Libvirt what to do with the various guests. And usually that is a clustered system. So you have a whole cluster managed as a whole. And you need to do that in order to schedule virtual machines onto different hosts, depending on the load on those hosts and the demands of those virtual machines. So it becomes more complicated as you go up.
And Randall mentioned the stack there a few times. I can't believe we haven't mentioned the term OpenStack more often in this interview so far. Now, the OpenStack movement is really big right now. You've got lots of people involved, big players like IBM, Red Hat, obviously, HP, lots of other people, Canonical, all these people coming in. Can you tell us a little bit about OpenStack and how that kind of fits, how KVM is powering the kind of OpenStack movement, if you see what I mean?
Well, KVM is the default hypervisor for OpenStack. So if you're running OpenStack, you're using KVM. So that's great. It's normally underneath, stashed behind all of these layers and plugins that OpenStack has. So it'll be hard to notice. But KVM is there, and that's what's empowered the various OpenStack. I'm not sure there is a common replacement for KVM in OpenStack, although there's no, it can be so it shouldn't be a problem. So we're mostly down there at the low level trying to optimize things, while OpenStack is a bit higher. The closer component to OpenStack for us is Libvirt with its various incarnations like Virt Sandbox, and also there is a new bridge mode that OpenStack uses, the Open vSwitch, and it's another component and the kernel model and user space, and it's not in a modularized design. You can switch between the Linux bridge and the Open vSwitch bridge alternative.
Excellent. That sounds really cool. Is there a big advantage in having all these different people contributing? I know Red Hat obviously massively involved in this, but you've got other people coming in. As I said, through the OpenStack movement, you're getting cooperation from the likes of IBM and all these other big names. Has that helped to accelerate the development, do you think, having all these people focusing on one thing rather than going off and doing their own things?
Definitely. It's a community of hundreds of developers all around, sometimes a specific contribution for KVM and the QEMU project, but sometimes various contribution to the Linux project and broader projects like improved bridging and all. So it's a tremendous gain for the project. For IBM, we're right there from the start, even in the Kubernetes days. but HP, I think, increases their KVM development probably because of OpenStack, and I'm sure that there are other companies that are doing the same, some big, some small. KVM empowers the cloud.
And we have to channel our co-host Simon Phipps, who is always very interested in things like governance models and community and so on. Now, it's my understanding that OpenStack and that kind of movement, and I'm probably getting a little bit beyond, I hope I'm not getting a bit too far beyond the KVM subject, but the whole OpenStack thing is governed by a foundation, is that right? Which Red Hat is a member of, and lots of other people as well, of course.
That's true, but not sure we have added value to that foundation because we're down there at the stack, and right now KVM is that stable and feature-rich that there's not lots of communication needed between the two, and I'm mostly getting a request here and there about Open vSwitch, nothing beyond that. Actually, KVM deployment for the enterprise is a bit more challenging in terms of feature set than the cloud deployment. Cloud deployment tends to be simpler.
We had you mentioned actually there, it's quite handy about management of large deployments and so on. We had some questions earlier on from Penk in the IRC channel, who was talking about Open Nebula and their tools for managing their and VMware and their tools for managing large installations, and they wanted to know what kind of tools you've got for managing large kind of implementations. Now, it's my understanding, I think Virt Manager, is it called Virt Manager? There's a tool that you can use. I've seen it used at Red Hat conferences, in fact, to run hundreds of VMs in one go and manage them all. So what kind of tools has like a sysadmin got at their disposal to use with KVM to manage a lot of different deployments at the same time?
Virt Manager is actually a graphical tool that is mostly good to manage a small set of installation, even I would say a single host. It can do multiple hosts and even up to hundreds of them, but it's not what it was designed for. It's possible. So if you do have such an installation, you can pick various options. If you're in enterprise, go ahead and pick the RevM. That's the Red Hat project. That's a product, and Overt is the open source project for that. If you are in the cloud, go ahead and pick OpenStack or Open Nebula. If you like to code something of your own, you can use the Verge and Verge directly, the Verge shell. So you have so many options. It's depending on your use case.
Excellent. That's just the point I wanted to kind of highlight, was the fact that there are lots of options, because lots of people in the IRC seem to be a little bit kind of worried about the lack of tools to manage these things, but there are so many things out there compared to lots of other platforms. So what's are you looking at things like embracing the, somebody asked earlier, are you looking at things like getting more into kind of embracing the data center? So from what you're saying, you would use something like, I don't know, something like Spacewalk maybe, or one of those things to manage your servers and then put KVM on top of them. And how would I manage a large, I suppose the same question, but how would I manage kind of like, a data center's worth of stuff? I would do that with a different tool and then use something for KVM as well.
There are multiple options here too. There's a project that calls CloudForm in Red Hat that will allow you to manage physical and virtual environment, but can't say I'm really into the details. I'm pretty sure maybe Avi knows, or I think our community members are more educated in that respect. We're mostly educated in doing some memory management and virtualization, low-level stuff.
Mm-hmm. And very quickly as well, I mean, we talked a little bit about community, and you've got a lot of people working on this. So what's the kind of governance of the project? KVM is a Red Hat product. So do other people have access to commit code to like a Git repo or something like that? How does that work? Do they submit things to you, you review them, and then they go in? What's the kind of process for that?
So KVM is just an ordinary Linux kernel project. I have a subtree that I manage along with Marcelo Tosati, also from Red Hat. And patches are posted on the mailing list. They're reviewed by the co-maintainers and by other people in the community. And then they're committed and sent onwards to Linux for merging. So there's no real formal structure for that. It's just like every other Linux subsystem. The other part of KVM, which is QEMU, is maintained by Anthony Liguri of IBM. And again, there is no formal structure there. There is a mailing list, and people post patches, people from different companies and very different things that they want to do. And we all review them, and then they are committed. There is a forum where the developers meet once a year. It's going to be quite soon in Barcelona this year, in a couple of weeks. And there we talk face-to-face and present our past and future work. It's all great fun.
Mm-hmm. So we had a fan of the show, Jorge Fabregas, who I have to mention him because he sent this incredibly detailed email about all the questions I'm supposed to ask you guys. So I want to make sure we address at least a couple of questions that he asked. So one of the things he brought up was this thing called RHEV, Red Hat Virtualization Layer or something, and that it's a slimmed down version of Red Hat Linux with the bare minimum required to run as a hypervisor. Do you want to talk a little bit about that and what's being done there?
All right, so it's all the initials you were talking about. It's a Red Hat Enterprise Virtualization. Usually it's -M says that the management that manages a cluster of machines, and each one of those machines, it's a node. It's called rev-h, meaning host. So in fact, it's basically just a regular Linux host. But we package it so it can run from a USB key or from a PXE. It's all cut off, all of the non-virtualization related stuff. So it's a sort of a bare bone in-memory hypervisor distribution.
Okay, and something like it gets it all the way down to like 200 megabytes. I guess I'd run off a key then, right?
That's right, exactly.
Wow. Okay. Also, were there challenges in stripping Red Hat down to that small of a space?
No, since Linux is pretty much a generic project that you can, like in Lego, you can take RPMs and build them together. Then it's based on the RPM mechanism. There was a couple of changes that needed to be done with RPM since some of the packages needed to be ripped out, or minimal things, but nothing huge that caught us under surprise.
Cool.
And because of the Linux kernel, the various device drivers, and KVM among them, QEMU, libvirt, VDSM, which is a daemon meant to use by Rev or the overt open source project. That's it, a bridge, nothing much.
Okay, and also he asks, if you go to Amazon, you look for Linux KVM, you find just one book, and it's in German. Are there any plans for a formal book on KVM?
So I'm not going to write one, and there is also a book, but it's in Japanese. So you have your pick, German or Japanese. I guess that perhaps if a new edition of one of the Linux kernel books goes out, then maybe there will be a KVM chapter in there, because it's really part of Linux. Most of the work for KVM is done by Linux in general, and so the actual KVM part is pretty small.
Maybe it's an opportunity for an excited community member to write one. Go ahead, let's see it.
Yeah, that might be great. That might be the good challenge there. So, Avi? What's your history? How did you come to the project, and what are you bringing to it?
How did I come to the project? Well, it was just by accident. I started working at the Kubernetes, and we were working for a different project, and then that other project didn't turn out so well. So we were looking for a new thing to do, and we came on this idea of doing virtualization. Before that, I did storage at Exanet, which was later acquired by Dell. So I was working on a distributed file system. So you would have several different hosts, each with its own storage, and they would collaborate to present a single unified file system to NFS and CIFS clients. And that was also a very interesting project, and I think it's now a Dell product.
Okay, and Dor, same question.
I started my career in a terabit router company that tried to compete with Cisco doing terabit router back in the bubble days. Technically, it went really well, but after some time that we got to the bandwidth, the bubble exploded, so we didn't needed that bubble. We looked for various ideas what to do with it. We tried to go through the high availability and the fault tolerant solution, and it was nice, but the bubble burst didn't help with that, so I moved to some other startup around managing blade servers and resources, again with high availability, and also that startup didn't went that well business-wise. So that's why I think Avi and I and plenty of other experts went to Kubernetes, because Kubernetes has really proven experience as entrepreneurs, and that's why we went there. So after some time working for the original idea, we switched about 2-3 times idea over there. That was both good and bad, switching ideas that fast. One of the ideas initially was by Avi. It was adding fault tolerance support for Xen. So you have a virtual machine running in lockstep on a different host. So if the first die, the other can continue from the exact same instruction without any notice. It was a really exciting project, but users wanted SMP, multiple cores, and it has a large performance footprint. So we just killed the project, and because of fault tolerance, we looked for an opportunity to migrate applications. And then Avi came up with the idea about KVM, and the business side had a story about virtual machines, virtual desktop, and the rest is history.
Cool. And I almost neglected this question, which I'm sure some of the guests are going to have, or some, not some of the guests, some of the audience is going to have. You're the guest. So Red Hat has commercialized the KVM and the whole package. Is there anything in the commercial package other than additional support that wouldn't be in the open source thing that I could just download for free?
The KVM is part of RHEL, and RHEL is totally open source. So we derive all of our bits from the Linux and project and many others. And over time, we collect set of patches. Some of them are fixes for bugs, and some of them are new features. So in fact, if you're going to look for the RHEL kernel, RHEL 6 is derived out of upstream kernel 2632, but 1 month after you branch it, then we already add patches to it, and more. So right now, the RHEL 6 kernel, after about 3 years of existence, 2 or 3, but remember, then it changed drastically from the originate, and everything can be downloaded, source code. There are other distributions that copycat RHEL, and it's possible to get them, but you won't get support. And more added value for Red Hat is the customer portal, reference architectures sometimes, certification to run, for instance, KVM with Oracle, KVM with SAP, and more like it.
And also, one more question from Jorge. I almost overlooked this one. It's actually sort of interesting. So VMware had a couple of events this year, VMworld USA and VMworld Europe. And at both events, apparently Red Hat had a booth promoting KVM and the whole virtualization products. What kind of reactions were you getting from the VMware people about what Red Hat's offering?
So we weren't there, so I don't know what reactions we got.
Oh, too bad. Can you
Good
make
answer.
something up for our audience? Just make something up. They loved it. They want to switch. There we go. Well, we're almost out of time. I want to make sure we've covered everything you guys want to cover. Is there anything that we didn't talk about that you'd like people to know about KVM?
Nothing comes to mind, Dor?
What's the initial stands for?
Sure. What do the initials stand for?
So it's a kernel-based virtual machine. The B is silent, so you don't pronounce it, and that's it.
Oh, well, that's simple enough. Okay, great. And I'd be remiss, and I would get email if I didn't ask the next two questions of each of you. So we'll start with Avi. What's your favorite text editor?
Emacs. I would say it's my favorite text editor. It's the one I know how to use. I keep trying to migrate to something more, like it's heresy, I know, but I want to migrate to a graphical tool that's easier to use. But I have the Emacs key binding ingrained into my fingers, so I can't really move away from it.
Okay, and your favorite programming language? Scripting language, I should say.
Programming language, I don't like any of them.
Fair answer. Okay, Dor, same two questions.
Want me to add bugs, so I want something simpler.
We had lots of discussions about what should be the right programming language for QEMU project, and all turned out in nothing, and C is there and probably prevail for the next 10 years, at least with this project.
Okay, very good, guys. Well, it's been a pleasure having you guys on the show and talking to us about something that's very essential as we move forward into the virtual world of computing. So thank you both guys for being on the show and talking to us today.
Thank you. Glad to be here.
Very good, very good. That was, oops, I scrolled off of their names. That was Avi Kavidi and Dor Lor. Hope I pronounced both of those roughly good. I almost said Simon, what do you think? Dan, what do you think?
Yeah, I thought it was really, really interesting. And I mean, we've talked about this before, but we've had a lot of interest, listener interest as well. So many questions in the chat room as we're going along. People emailing questions before the show. So clearly, this is a hot topic right now.
It is. Well, I mean, it's at the core, to be able to take the bare metal and say we're divvying it up amongst these, 5 or 10 users. It's more than just sharing the stuff around. It's more, more than just being able to share the machines. It's also being able to migrate it, like they were talking about. I mean, I'm sure, like when you're on an EC2 instance or any of these other big cloud providers, you're going to. It's going to, and they have to take the machine down. I'm sure you basically just do live migration and move this stuff over. I forgot to ask, but I think EC2 is also using KVM technology or something similar to it. And so it really is starting to be, even here at Media Temple, my current client, for at least another couple of weeks, are talking about bringing in OpenStack-based machines, and they just announced that, I think, yesterday, as products, because this is where people want to go.
And OpenStack, I mean, the whole goal of the project, the movement, the OpenStack movement, is to make it one common thing that everyone will use and will become the dominant kind of platform on the for cloud infrastructure and so on. I can't believe I used so many buzzwords in that one sentence, but yeah, it seems to be a really big thing. And something we didn't really get into with the guys there was the Open Virtualization Alliance, which sounds very sci-fi, but I was talking to Scott Crenshaw, who's the head of cloud solutions for Red Hat, and he was telling me about the Open Virtualization Alliance. So they're really trying to bring everyone together, and they've got IBM and HP and other people working together in the Open Virtualization and the OpenStack movement, which is no small feat.
And of course, we were talking about the live chat room. Live chat room just corrected me 3 different ways. No, it's Zen that Amazon's using, so it's not using KVM. It's the other. We've actually had Zen on the show too a long time ago. Actually, I should have remembered that from that show. But yeah, so it's cool. So speaking of upcoming guests, there's my awkward transition. Completely awkward because I was completely disconnected there. We've actually filled out, or except for 1 week, we filled out the entire Q4 schedule. So we've had a couple of new additions since our last show, which was a couple weeks ago. Next week, we'll be talking about Base Rock, which is for embedded Linux systems, a way of bringing down the size of Linux, making it fit on a key like we're talking about today. Just added to the show, another, I think there's a Red Hat project, Image Factory, which is a system for creating all these VM images that you want to run in some sort of automated way. They've just been added to the schedule. We're also bringing on the chatbot, which is a Jabber-based chatbot that allows you to communicate and perform actions based on communication there. Also coming up, Poodle, which is an online translation management tool with a translation interface, and Zanata immediately following that, which has exactly the same description. So we'll get to compare those, two different implementations of that. Just added to the schedule as well, the Foreman, which is something that manages startup for provisioning hosts. So in other words, when you have one of these server farms and you want to say launch something, there has to be some way to connect this thing that's launching with what image does it get, what settings does it use, what kind of configuration management tool like Puppet gets fired up when it first wakes up. So the Foreman apparently does that. Also just added to the schedule since last time we've chatted, Broadleaf Commerce, which is a fully customizable open source e-commerce framework. Dan, I think I beat you for buzzwords there. I think that's more in a row than you just used.
Damn
I think I got it. Win. I won that one. All right. Round
Triple
two.
word score.
Rambo. Yes, exactly. my boggle score is amazing there. And then also rounding out the year, we have Cake PHP, which is a web framework, and Yesod, I don't know how to pronounce that, which is a Haskell web framework, which advertises all sorts of reliance and things like that. So again, lots of people coming up, more people even still in the works to be scheduled. If you go to twit.tv/floss, you'll see our big spreadsheet that talks about our schedule and also about all the people I'm still trying to get onto the schedule. You can follow us on Floss Weekly on Google+, and also Floss Weekly, all one word, on Twitter and Identica. And I post things to both of those as we get new guests added to the schedule. We have a very lively chat room today. It's because they went to live.twit.tv. As we're taping this, it's 8:30 a.m. Pacific time on Wednesdays, and the live chat room allows you to watch the show as it's being taped live. You can see all the mistakes we make behind the scenes, and you can also contribute to the show, as many people did today. I really appreciate that kind of feedback. It's really good for us. You can follow me personally at Merlin, M-E-R-L-Y-N, on Twitter. You can also follow my Google Plus handle at Randall L. Schwartz. I try to post 3 or 4 interesting things a day there and also describe where I'm going to be, such as next week. I won't be doing this show because I'll be out on the Mediterranean. I'll be somewhere between, for the next 2 weeks, I'll be somewhere between Genoa, Italy, and I'm out to Israel and Greece and Turkey and a bunch of other places whose I can't remember, but it'll be yet another one of those insight cruises that I take all the time. So I won't be here for the next 2 weeks, but we'll have a very trustworthy co-host managing the shows for me. You, Dan, and Simon, and everybody's going to take care of that for me. We have various parts of the, no, I just said that. Also, I mentioned briefly, I'm only at Media Temple for another couple of weeks. I'm still looking for something to fill my late November and December schedules and onward. So if you're in the need for, I like to use my own platform every once in a while for this. If you're in the need for somebody of my skills, I am now available. So please let me know, merlin@stonehenge.com, if you have opportunities for me, probably anywhere in the U.S., although I think I'd prefer West Coast. But they make me an offer that I can't refuse. That's all pretty good. I think it's all I want to plug here. Oh, just one more thing. If you follow my Google+, you'll actually see that for the last 5 or 6 weeks, I've been experimenting with what Steve Gibson originally talked about, which is a low-carb diet. And I've got to say, it is both tasty and working. I've lost about 10 pounds since in the last 6 weeks. And I'm really happy with that, and I'm still on the diet. I'm still very happy eating the insides of bacon cheeseburgers without the buns. Oh my! I had 2 of those yesterday, and it was totally on my diet. I can't believe how cool that this diet is. I wish I would have discovered this 20 years ago, that you can lose weight simply by eating cheeseburgers. Boy, that's just incredibly crazy. Dan, what do you want to talk about besides my diet?
Well, besides losing weight with cheeseburgers, yeah. Well, I'm obviously, if you want to head to my website, which you see if you're watching the video feed, which is danlinux.org, you can find links to things like Linux Outlaws, which is a weekly show about Linux and open source software, where we talk about things like KVM, in fact. And we've had some of the people involved in the projects and OpenStack and so on. So go and check that out. Just do a search for Linux Outlaws, we'll come up. Also, I've been actually, I'm going to take a leaf out of your book here, Randall. As soon as you're using this platform as well. I'm going to mention the fact that yesterday I did a podcasting course at a place called FACT in Liverpool, which stands for the Foundation for Art and Creative Technology, and not the Foundation Against Copyright Theft, which is what some people thought it was. So I did a one-day course down there, and we're going to be doing another one in November. So if you head to my website at danlynch.org, and you can obviously travel to Liverpool, you can come and learn about podcasting if you like, and hang out with me. And just go and check out there. You can find my Twitter feed and Google Plus and Facebook and all those things on the website. So that's the best place to go. danlynch.org. There we go. I think that's sufficiently plugged.
Sufficiently plugged. That sounds great. And Dan, thanks once again for taking the co-host spot for me. And I hear you've got you're one of the hosts coming up the next couple of weeks, right? I've got to look at my schedule here. I think one of the shows you're actually hosting. Are you hosting? No. Yeah, you're hosting like 2 weeks.
Yeah, I am. Yeah. I get
cool.
the captain's chair for a week.
Indeed, the big mic. Yes, the big mic. So we have the shows coming up the next 2 weeks. We have Aaron Newcomb is hosting next week, along with Simon Phipps as the co-host. So nobody will have to channel Simon Phipps next week. He'll actually be here. And then you're hosting the following week with Aaron. So it'll be sort of an interesting combination show there as well. So again, I appreciate you taking over the spot when I'm gone, and that way we keep the show going, which is always kind of nice. Let's see. I think we're just about done. So without further ado, we'll see you all again next week on FLOSS Weekly.